Hi everyone. So today we're going to talk about weather instruments. Let's get started. So first we need to know the difference between weather and climate. Weather is the short-term state of the atmosphere, and it can change within minutes or even hours. Kind of an example would be rain or snow, sunny weather, etc. They change within minutes or hours. Climate, however, is the long-term pattern of weather. For instance, the average weather over many years in one specific place. Tropical climates could be an example. Polar climates more near the poles could be an example. Near the poles, it's pretty much always cold. That's the climate over there because it's the long-term pattern of weather in that area. Near the equator, it's pretty much always warm. That's why climate is long term, weather is short term. So go ahead and write this down in your note packet. Weather, atmosphere is all the gases surrounding the earth, and the atmosphere creates weather, which is the short term state of the atmosphere. So, we also need to talk about how clouds form to understand weather because we experience clouds every day, right? So here's how a cloud forms. When it's sunny out, it warms up the air near the ground. When the air near the ground gets warmer, warm air is less dense, so it starts rising. As it starts rising, if you remember, as we go higher in the atmosphere, the pressure gets lower, right? The air pressure is lower, meaning the air molecules are much farther apart in the up here. And that's why as the warm air is rising, it also expands. Okay, because of less pressure, the air molecules can spread out more. And because it's spreading out, it also starts to cool down. And the thing is, as it cools down, we start condensing the water vapor that's in the air. Condensation, remember, is when we go from gas to liquid, right? And when water vapor cools down, it will turn into water droplets. And that's exactly how what clouds are. Clouds are a mixture of gas and water droplets, and some other small particles. So go ahead and write. Actually, we're gonna write this down in a bit. But clouds form when warm, moist air, the air needs to be warm to rise, rises, expands, cools, and condenses. You can remember this with rec. Okay, warm air rises, it starts to expand, and it cools and condenses to form water droplets that form clouds. So go ahead and write this down in your note packet. Clouds form when warm air moist air rises, expands, cools, condenses. It also needs to be moist because you need the water vapor within the air to turn into water droplets to form those clouds. Let's talk about weather instruments. How do we measure weather? You're probably familiar with this. We measure temperature with a thermometer, and a thermometer can measure between Celsius or Fahrenheit. Go to reference table page 13. Go ahead and open that up. You'll notice that we have a temperature chart on reference table page 13. And this chart will help you convert temperature between Fahrenheit, Celsius, and Kelvin. It gives us the temperature at which water boils in all three different units of temperature. We have room temperature in all three different units. We also have when water freezes here. Water freezes at 0 degrees Celsius, water boils at 100 degrees Celsius. So you don't really need to calculate for temperature. You can just use your reference table to convert between units. And remember, if you want to figure out what the interval is for any scale, you use this formula. You can pause this video and write it down in your notebook. Bigger number minus smaller number, meaning on a scale, pick any two numbers, and whichever two numbers you pick, you should write the bigger number minus the smaller number divided by the number of jumps between the numbers. So I picked 0 and 20. There are 10 jumps between 0 and 20. So I did 20 minus 0 divided by 10 is 2 degrees Fahrenheit, meaning every single um, point or interval on this scale is 2. So if this is 0, it's 2, 4, 6, 8, 10, and then 12, 14, etc., etc. For the Celsius interval, my interval is 1 degree Celsius, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And for my Kelvin interval, this is another unit of temperature. My interval is 1 Kelvin. So each increment is going up by 1. If you would like, you can write this down in your reference table as well. We normally use Kelvin for much larger numbers for temperature. For instance, the temperature of the interior of the Earth, or the temperature of the sun or a star, and so on. So, another thing that we tend to measure from weather is the atmospheric pressure. And to measure the atmospheric pressure, we use this device called a barometer. And go ahead and open your note packet and write this down. So, the instrument barometer measures air pressure. Remember this. Also, remember what it looks like. So, if you go back to your reference table, page 13, you'll also find this chart right here. And this is the pressure chart. Notice that pressure can be measured in 2 units, millibars or inches of mercury. Hg stands for mercury, and it says so in the bottom here as well. So, the reason we measure pressure in inches of mercury sometimes is because a long time ago in 1643, the unit inches of mercury came from the design of the first mercury barometer. Remember, barometer measures air pressure, and this was the oldest barometer called mercury barometer. It had mercury in it, and whatever the atmospheric pressure was, that pressure would exert pressure on the mercury and cause some of that mercury to rise up this column. And however high up the mercury went in that column, you could figure out what the atmospheric pressure was. That's why barometers measure atmospheric pressure. All right. And 1 atmosphere is the sea level air pressure. So the increments for millibars is 1 millibar. I'm still using the same equation. So each increment is going up by 1. And the increment for inches is 0.01 inches. Same equation. So each increment is going up by 0.01. If you need to, go ahead and write this down in your reference table. So another thing we tend to measure in for weather is humidity, the amount of moisture in the air, and we use a device called a psychrometer to measure humidity. So how does it work? This is a device. This is a psychrometer, and it has 2 thermometers attached to it. One is a regular thermometer, and one thermometer has a little bit of cloth on it with and some water. And the regular thermometer just tells us what the room temperature is, and the reason that we put a cloth around this thermometer is because we want to know how much moisture there is in the air. If there's too much water vapor in the air, then if we spin it around like this, the water from this cloth won't evaporate. But if the air is really dry, the water from this cloth will evaporate. And how much water evaporates will tell us what the how much water vapor there is in the atmosphere already. We just compare between the dry and the wet thermometers. We'll talk about this more further in the future, but this is how you do it. So go ahead and write this down in your notes. A psychrometer measures humidity, thermometer measures temperature, barometer measures pressure. And remember what everything looks like. Next is wind speed. So wind speed is measured with a device called an anemometer. This is a tough one to remember. An anemometer, it kind of spins like this when the wind is blowing, and it measures the wind speed. Anemometer. Go ahead and write this down in your notes. An anemometer, it looks like this, measures wind speed. It has these little cups in it. And finally, wind direction is measured by a wind vane. You might have seen this before already, maybe in cartoons. And this wind vane has a compass thing on it, and it shows us in which direction the wind is blowing. Wind vane. Go ahead and write this down. A wind vane measures wind direction. So, how do we even measure all this in the atmosphere? We use something called a weather balloon. This is a giant balloon that's normally in weather stations, and it's attached to lots of weather instruments. A lot of weather instruments are attached to it, and there's also a parachute. And people at the weather station just let go of this balloon, and it just flies into the atmosphere. And all these instruments measure temperature, humidity, air pressure, wind, and many other data, and that data gets sent to the weather station. It also has a return address attached to it, so if anybody finds it, they know how to return it or mail it back. Weather balloon. And that's it. Thank you.